Hello! In this video we will talk about DC motors and how they work. The direct current motor, or DC motor for short, is the most commonly used actuator to produce continuous movement. Its speed is straightforward to control, and with some additional circuitry, so is its direction of rotation. DC motors come in many different sizes with different properties. The speed of DC motors can vary between a few revolutions per minute up to several thousands. The speed of a DC motor is almost linear to the supplied voltage, and the torque is determined by the amount of current flowing through the motor. To change the direction of rotation, the direction of current needs to be switched. DC motors are used to rotate pumps, fans, compressors, and wheels, to name a few use cases. By adding some positional feedback control to a DC motor, you get a servo motor. More about them in another video. We are now going to demonstrate how to control a DC motor with an Arduino. We are using a transistor to control the speed of the motor. The diode and capacitor work as protection for the circuit. To follow along, you will need an Arduino, a breadboard, a DC motor, a transistor, a 1000 ohm resistor, a 100 picofarad capacitor, a diode, some hookup wires, and a 9-volt battery. First, connect the transistor to the breadboard. Connect the emitter terminal to the battery's ground, base to pin 9, and collector to the DC motor's ground. Connect both the diode and capacitor in parallel with the motor. The diode should be oriented from the motor's ground to its power. Lastly, connect the batteries and motor's positive poles. We are not able to control the direction of rotation with this circuit. For that task, we would need an H-bridge. Next, the code. First, the DC motor pin is defined and its mode set. In the loop, we use 2 for loops to vary the speed variable between 0 and 255. Inside the for loops, we analog write the speed value to the DC motor pin. Additionally, we use short delays to increase reliability. DC motors are split into 2 main categories, brushed and brushless. Their working principle is the same, but the cost and efficiency vary a lot. A conventional brushed DC motor consists of 2 main parts: the stationary body, called the stator, and the inner rotating part, called the rotor or armature. The stator consists of the motor housing, permanent magnets, power terminals, and brushes. The rotor includes the shaft, commutator, coils, and iron discs. The commutator is split into multiple isolated segments connected to separate coils. The iron discs strengthen the magnetic field generated by the coils. Let's look at the working principle through an animation of a DC motor with a single coil. The magnets create a strong magnetic field through the rotor. A voltage is supplied to the terminals. Current flows through the brushes and the commutator to the winding. The magnetic field induced by the current flowing in the winding will interact with the external magnetic field. This results in the rotor turning so that the magnetic fields seek to align. When the rotor has turned 180 degrees, the brushes touch different commutator segments. This changes the current flow through the coils, causing their magnetic fields to change as well. Again, the rotor turns to align with the external magnetic field. The brushless DC motor is quite similar to the brushed version, but lacks the brushes and has the magnets and winding swapped. The rotor is connected to the magnets and thus no physical contact is required. The advantages of the brushless DC motor are higher efficiencies, high reliability, better control, and most importantly, no wear out. However, they are much more expensive. That's everything for this video. Thank you for watching and see you in the next one.